So in this one, we want to find two vectors that are orthogonal to both v and w, where v is 2i plus j plus k. W is 3i minus k. So we talked about a product, a particular kind of vector product last time that does that for us, right? The resulting product of your given two vectors will be orthogonal to both the given vectors. So what was that product? The cross product. Woo, yay! It's in the product hall of fame, right? The cross product. Okay, so how are you going to set this up? Okay, you're going to set it up as a determinant of a weird kind of matrix, right? A matrix where the top line is vector entries. That's kind of weird. So across the top, I, J, K. And then the entries in the middle will be numerical. What numbers will they be? 2, 1, right? And 1. And then so those are the components of V for the middle entries. And then the last row, 3, you don't see a J, right? So 3, 0. The J component is 0, and then what? Negative 1. There we go. V cross W? Okay, let's try it. So cross out the first column, ignore the top row now, and just look at the determinant of the submatrix that's left. So 1, 1, 0, negative 1. Take that determinant. What do you actually get? So negative 1 minus 0, but are we going to include that word? No. So negative 1, what, I? Yeah. And then cross out, so that's your first component. Is that okay? All right. Cross out middle column. I feel like I'm ignoring you guys over here. Maybe if I back up, I can get more people in my field of view. Okay, so do you see the numbers that are left? 2, 1, 3, negative 1. Okay, automatically, what operation comes after the I component?
Minus.
Minus, all right. And then what's the determinant of 2, 1, 3, negative 1?
Minus 3.
So negative 2 minus 3, right? And then that's a J component, right? Which will actually end up being what when all is said and done? Well, negative 5 minus a negative 5, so
Plus 5.
so 5, yeah. So be careful, be wary of those negatives. If there's a lot of negatives, I recommend you write out your work like I just did, so you don't make a mistake. Right? And then cross out the last column. We've got numerically 2, 1, 3, 0. Take that determinant. What do you get there? So what's 2 times 0? 0. Minus 3, right? And then, whoops, I almost put J. I meant to put K. All right, so what does that turn out to be? Negative I, if you like. You don't need the negative 1 there. Then what did we say? Plus 5J. And then minus 3K. Does that seem reasonable? Is there a way to check your answer? The dot product is an orthogonal vector detector, right? Let's just do one. I mean, if you take the dot product with both V and W, V cross W, dot it with both V and W separately, right? You should get 0 both times. Let's do it for W. What would W, so this guy dotted, this is the answer, we're just checking it, right? What would W dotted with V cross W be? Well, it better be 0, right? You're exactly right. So let's see. So we're going to take 3 times negative 1, right? Let me think. Negative 3. And then, 0 times 5? 0. And then hopefully we get a positive 3. Negative 1 times negative 3, positive 3. Yep, works. And then it'll work for W, or not W, but V dotted with V cross W as well. I'll let you guys check that, but if we did everything right, that'll be 0 also. So this is more of just a check on your work. This is the answer right there. Does that make sense?
How are we supposed to know to find 2 vectors, though?
Oh, it does say find 2, doesn't it? It does say find 2. Any ideas? I mean, I don't want to, wait, before you answer that, I'm feeling lazy. I don't want to do a whole lot more work, do you? So we need to find another vector essentially that's kind of going in the same direction as v cross w, right? But not v cross w. Is there a way to find a vector going in the same direction as a given vector, but make it not the same? What do you think? Multiply by a scalar. You could take -1, right? Times the vector. So in other words, two vectors are parallel if they're scalar multiples of each other, right? That's one of the rules you learned back in 12.3. So, well, okay, if we come up with a vector that's parallel to v cross w, won't it also be, since v cross w is perpendicular to v and w, won't the parallel vector also be perpendicular to v and w? Yeah. So it's real quick. So another answer would be, maybe you could multiply by any constant other than 1, but maybe multiply by -1, what do we get? I minus 5j plus 3k. So we could take that guy as well. They're different vectors, right? Of course, the only difference here for the second one is it points in the opposite direction. It even has the same length as v cross w.
And if those were in component form, that would be fine as well.
Yeah, no.
Okay.
So let's, you know, when I was taking Calc 3, I remember it. It was 25 years ago. How did that happen? Where did all those years go? 25 years. Do I seem that old? I hope not. 25. So the age. It's probably longer than you've been alive, right? I need to go home. I just made myself depressed. So 25 years ago, when I took Calculus 3, I didn't like IJK form either, right? Because I was comfortable with component form, as many of you are. So and I was just being stubborn, right? So it's like the James Bond thing. Okay, how could you possibly relate the IJK form to the James Bond thing? When I was a kid, James Bond was a guy named Roger Moore. And I thought he was great because I was really young and dumb, and I saw his movies first, and I thought they were really cool. But before Roger Moore, there was one other dude, I don't even know who, and then before that, Sean Connery. One other dude did like one movie in between, I think. And of course, my dad thought Sean Connery was better, whereas I thought Roger Moore was better. Who was right?
Sean Connery was better.
Yeah, Sean Connery was better, right? I mean, and if you try to watch any of those movies these days, they're really cheesy. I couldn't even sit through it these days. But anyway, back in the day, they were cool. But the only why did I like Roger Moore better? This is the point of the whole analogy, because that was the one I saw first. Why do you guys like component form better? Because that's the one you probably encountered first. So my moral of that story, of that, you know, it was kind of a stretch connecting the two. The moral of that is don't be afraid of IJK form. So here's the rule we'll go by. If you start out in IJK form, let's end up in IJK form. Yeah? And then you'll get practice with both, right? If you start out in component form, end up in component form. And I probably won't care if you start in component form and switch to IJK form, because that's fine. Because you're more used to component form anyway.